Well, the most common things that we're going to factor are actually trinomials. And that's going to be things that basically have the shape. We're going to have something squared in it. We're going to have just a something sort of alone. And then we'll just have a constant. And we have to try to factor it into two factors. And actually, this is where you sort of undo all the foiling stuff that we do when we actually multiply out two binomials. So let me sort of give you a sense of the theme of this and some pointers. And let me just do a whole bunch of examples so you can sort of remind yourself of how all this goes. Suppose that we take a look at the following. We want to factor 3x squared minus x minus 4. OK, now the first thing you might want to do, which once you sort of get in the habit of it can be really quick, is to go through all the easy things. First of all, is there anything I can pull out of all of them? Is there any kind of common factor in all these monomials? Answer, no, because this only has a factor of 2 and 4. This has only x. This has a 3 and x. I can't pull anything out. Any grouping possibilities? I can group out an x here, but then I'm still left with that 4 dangling in the wind. So this doesn't look too good. So let's just see if we can try to factor this and say, well, what would it look like to factor this? Well, it would have two pieces if it were to be factorable. So let me actually try to write in those two pieces here. And these are both going to be binomials. They're going to be two pieces to this, two pieces to this. And now what are we going to do? I'm going to want those two pieces to have the property that when I FOIL it all out, you know, ding, 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 it's going to equal this. So let's just think through how that's going to play out and the possibilities. Well, the first two terms here, I'd want them to be 3x squared. Now, there are a lot of ways of breaking this up. I could break it up like, for example, a 3 here and an x squared here. That would work. I could put in a 3x and an x here. I could put in an x and a 3x here, and so forth. I could do a lot of possibilities here. In fact, there's even more exotic ones, but I won't even think about those right now. Let me try some easy one. Actually, putting in a 3 and an x squared here is not a great idea, only because then later on in life when I'm doing the inside stuff and the outside stuff, I'm going to get some x squared somewhere in here. And that actually might not play out too well since this is the only x squared I have. So what I traditionally try to do is to break up the x squared by putting some of the x here and the other part of the x here. So let me put a 3x here and an x here. Now, by the way, I am not giving any kind of warranty or guarantee that this is always going to work. But this is the way most of these things tend to go. So I'm trying to show you a general way of starting to think about it and seeing if it works. If this doesn't work, you'll have to try something else. So don't panic. OK, anyway, notice this has the pleasant property that when I multiply these two things out, I do get that first term. OK, but now I've got to get everything else to work out. Now, how am I going to get everything else to work out? Well, let's see. These two terms have to multiply to hopefully give me the minus 4. Now, if you think about that for a second, the product of two numbers here is going to be negative. That tells me that the signs of these numbers have to be opposite. You see that? Because if they're both positive, then that product would be positive. And if they were both negative, that product would be positive. So in fact, what I have to do is have opposite signs. Okay? And it has to be two numbers whose product is 4. Well, there are a lot of possibilities. There's 4 and 1. There's 2 and 2. There's all sorts of possibilities. So what we have to do now is think about which possibility is going to give us everything else. Let's think of the 2 and 2 possibility for a second. Imagine I write in a 2 here and a 2 here. Can you see them in invisible ink? There they are. What would happen? I would get the 4 over here, but this would give me a 2x. And this would give me a 6x. And the question is there any way to combine a 6x and a 2x and make it into just an x by itself, or a negative x? And if you have a 6x and if you add it to 2x, or if you subtract it from 2x, I'm not going to get it. So that 2 factor doesn't look too good. So it's probably going to be a 1 and a 4 factor. That's the next thing I'm going to try. It may not be, by the way. I want to point out, it may not. This may not be factorable. But if it's going to be factorable in an easy, nice way, then probably we're going to have a 1 and a 4 thing. But I've got to consider all the possible signs. For example, 1 minus 4, minus 1, 4, and then putting the 4 here maybe. 4 minus 1, and then minus 4, 1. OK, a lot of things to check, and let me show you how I would actually check those things. So let me write the problem back here. This problem is 3x squared minus x minus 4. And let me write down all those cases I have to consider for that bottom thing. Because here's where we are right now. We have this. We know it's going to look something like that. And now what I want to do is figure out what's going to go in these holes. Well, what are the possibilities? Well, I could put in a plus 1. But then I have to put a minus 4 here. I could put a minus 1 and then put a 4 here. I could put a 4 here and a minus 1 here. These are positive. And then I could put in a minus 4 and then a plus 1 here. Those are all the 4 possibilities of putting the 2 different signs in different places. You see, they're all different possibilities. We know the 2, 2 thing can't happen because I can't get that middle term. And now what I'm going to do is just sort of go by trial and error and see which one of these actually might give us the answer. Maybe none of them will, but let's try. So the first one, if I do this, how would that look? Well, let's see. The first terms give me the first term here. The inside term gives me a plus x. The outside term gives me a minus 12x. So that combines to give a minus 11x. So already I can stop the game. I know that's not right. So let's move on. What about here? Well, in this case, the first 2 terms, of course, are good. The inside term, I get a minus x. The outside term, now I get a plus 12x. That gives me a plus 11x. Hold the presses. We're done. Doesn't work. Let's go there. This might not be factorable, folks. Who knows? Here, what I see is the first term is OK. Then I have a 4x, and then I have a minus 3x. So a 4x minus 3x is actually plus x. So close. Do you see it? It's still plus, and I need minus. So even though I don't want to, I have to throw it away and hope for the best down here. Let's see what happens here. Here I see 3x squared. Here I see a minus 4x. Here I see a plus 3x, and a minus 4x plus 3x is a minus x. And the last 2 terms give me the minus 4. This is actually a correct factorization. Great. So in fact, this is the way that one can think about trying to factor a trinomial into 2 binomials. There's 2 terms in each of these things. And the idea is to break up that term with the squared in it in a reasonable way, and then try to fiddle with the constant term, thinking about the signs, and seeing how the signs would play out to make this thing work, and then trying the possible cases. Now, this is quite an exorbitant way of doing this. In reality, you might actually be able to try them pretty quickly once you get into the hang of it.